Hello and welcome to From ELK to Elastic Observability, More Than Just the Logs. Today's webinar is sponsored by Elastic and produced by Actual Tech Media. My name is Scott Becker and I'm excited to be your moderator for this special event. Now, before we get to today's great content, we do have a few housekeeping items that will help you get the most out of this session. First off, we want this to be an informative event for you, so we encourage any questions in the questions box in our webinar control panel. Not only will we have team members responding to questions during the live event, but we'll also have a dedicated Q&A session at the end of the presentation where we'll discuss in greater detail some of the top questions that you ask. That Q&A panel is also the place to let us know about any technical issues that you might be experiencing. A browser refresh will fix most audio, video, or slide advancement issues, but if that doesn't work, just let us know there in the Q&A and we'll provide further technical assistance. Now, next, in the handout section of your webinar control panel, you'll find that we're offering several resources. I'd especially like to call your attention to a link to get started with Elastic. Some great resources on there. Now, at the end of this webinar event, we will be awarding a $250 Amazon gift card to one lucky registrant. Of course, you must be in attendance during the live event to qualify for that prize. Official terms and conditions of today's prize drawing can be found in the handout section as well. Just scroll to the bottom and you'll find the prize terms and conditions link there. Now, finally, one of the best benefits of this event is the opportunity to ask a question of our expert presenters. So to help encourage questions, we have a special additional for you. That's another Amazon gift card, this one for $50 for the best question. At the end of the event, we'll look at all the questions, pick out the very best one, and contact that prize winner. So with all that out of the way, let's get to today's fantastic discussion and demos. We've got a jam-packed presentation today. So it's my pleasure to introduce you to our presenters. We have Navi Viswanathan, who's Principal Solutions Architect at Elastic, and Shankar Subramaniam is Principal Solutions Architect at Elastic. So I'm going to turn things over to Navi.
I'm Navi Viswanathan, and I'm very excited to be talking to you. We have a lot of people on this webinar today, probably from various roles and goals. Some of you are probably using Elastic in some capacity. Some of you just heard of Elastic as a search application. Our goal is to make sure you leave with the understanding of how Elastic can help you implement a complete end-to-end observability solution. A quick look at the agenda. We will first talk about the evolution from ELK to Elastic, specifically Elastic Observability Solution. Then we will look at some of the ways to ingest data into Elastic and some common patterns, followed by a demonstration of the solution. Then my colleague Shankar will talk about AIOps, leveraging ML, and he'll also conduct a demo. And finally, we'll wrap up with Q&A. As many of you know, Elasticsearch was founded as a full text search engine. The goal was to help users find relevant information faster at scale. Affectionately called as ELK stack, was often used for ingesting and querying of log files. Over the years, Elastic as a company has evolved to serve much broader scope, and ELK stack has evolved into a highly scalable, distributed, trusted data platform that provides end-to-end observability solution, security information and event management solution, and enterprise search solutions. The position of Elastic in all these three solution areas are also validated by the industry analysts such as Gartner, IDC, and Forrester, to name a few. But the principle still remains the same: helping find relevant insights faster at scale with the power of search. Some of the key capabilities of the platform is the reason for this evolution. The ability to ingest data from various sources, such as applications, network, and infrastructure, including logs, metrics, and traces, paired with rich visualization layer to quickly find, diagnose issues, powered with ML capabilities like anomaly detection, makes it a great fit for observability. When it comes to security, the ability to ingest and correlate various security data such as logs, firewall logs, endpoint logs, along with machine learning capabilities for detection and incident response, customizable alerting capabilities, and integration with SOAR platform makes it a great fit as a SIM platform. Under all that is Elasticsearch. It still remains as the core of the platform. It is so powerful that many of the observability solutions out there is probably using Elastic in the backend. Now let's look at observability. The ultimate goal of observability is to enable teams to proactively identify and resolve issues before it impacts the end user. To be able to do that, first you will need to have a full visibility into the complete stack. You're going to need to collect and analyze data from every layer of the stack, including applications, infrastructure, and network components. And if you're running microservices, then you are going to have to collect logs from the containers as well. Then you are going to have to get granular into the applications by collecting application logs, metrics, traces, and events. So you can understand the root cause by correlating these events. For example, if you notice a CPU spike in a particular host, you can track it down to a specific application causing it, to even to the function call made by that application. Then you're going to need to have a rich analytics capabilities. So you can start to see patterns and take actions. And of course, once you have a large set of data, tracking data from different applications, you're going to need to leverage machine learning capabilities to do the heavy lifting for you. And finally, you want to be able to communicate and collaborate with the respective teams to make sure every team has access to the right data so that they can effectively monitor and troubleshoot systems. Elastic have you covered in all these areas. Of course, the advantage of Elastic is to be able to have all these metrics, traces, and logs data in one platform. This is where the whole is really larger than some of its parts. And we are seeing more and more technology leaders are looking to consolidate platforms for many reasons, including cost optimization and even to gain more ROI and value. With Elastic, when you bring all this data from different systems and consolidate into one platform, you can keep all this data indexed for as long as you want in a cost effective way. For example, let's say that you're ingesting a 1 terabyte a day, and you can decide to hold this data, let's say for 7 days, that is readily accessible, and you can move the rest of the data to a little cheaper storage solution. The beauty of doing this with Elastic is you can access even the data that was put away. There's no need to prep the data or rehydrate them. Just by sliding the date range, you have the immediate access to this data. In Elastic, we call that a data tiering. And why do you need all this data? Because it allows you to have an integrated context everywhere. Like I mentioned in an example earlier, if you see a CPU spike, you are able to track it down to the host, to the application, to the a specific functional call, even to the kernel level information. Now, there is also value in having historical data so you can start to see patterns and, most importantly, leverage machine learning models. As you know, ML models work the best when you have massive amount of data. And it'll allow you to find a needle in the haystack. With Elastic, you can even bring your own models. So in summary, with Elastic as a single platform, You will be able to achieve end-to-end observability by bringing in data from various sources, logs, metrics, traces, and you can observe end-to-end from starting from the end user experience to the database calls to even the kernel level information. Now, how do you get all this data into Elastic? Let's talk about that. It has three components: ingest, store, and consume. On the leftmost, we have all the different data sources that you can bring data from. It could be an Elastic agent running in a host. It could even be a lightweight data shippers like a Beats framework. It could even be an OpenTelemetry data. Elastic has native integration with OpenTelemetry. Now, all this data can directly go into Elasticsearch, but the best practice is to have a layer in between for transformation enrichment of data. You may want to use applications like Logstash or even leverage Elasticsearch's native ingest pipeline capability. And why would you want to do that? For example, if you're collecting logs, you may want to drop some fields. You don't want to store them. And you may want to enrich, like if you have an IP address, you may want to associate a geo IP to it. Elastic has native capabilities for you to be able to map IP to a geo IP, so you can map them in an actual map. The next is to index this data, store and analyze them. And that happens in the Elasticsearch. And once that is done, now it's the time to consume the data. The most popular way to consume data is through Kibana. Kibana is the visualization layer. You can not only visualize data here, you can also administer the stack, create alerts, things like that. You can also consume this data directly by calling APIs. And these components are loosely coupled. You can build your own applications and interact with data that is in Elastic. Now, Shankar will go into a bit deeper with a real life example of a deployment model. Shankar?
And before Shankar talks, I do want to jump in with a quick announcement. Just that I want to thank Jeffrey in the audience for pointing out a problem with the handout link on getting started with Elastic. It's fixed now, so it goes to the Elasticsearch page. But Shankar, sorry for the interruption there. There, go ahead.
No problem. Thanks, Scott. Hi. I'm sorry. I got some sore throat and stuff like that today, just under the weather. But I'll try to make it small. Now, the idea of using Elastic comes into the picture where you have a very large distributed system architecture in your existing system, and it could be in just one region, multiple regions, multiple uh, you know different countries, and it's completely distributed across the world. So when you have data resource across the different resource, different providers, you might be having some data which are hosted on your cloud and different clouds, and some of those hosted data maybe in your on-prem environment, and you wanted to have the functionality of Elastic which can serve for the complete, you know for all your data sets. So with Elasticsearch, you can pretty much push any kind of data into the system. I've just given you a few examples. Say, for example, if you're using a stream set as a broker, a Kafka as a broker, or anything, any kind of ingest layer you might be using, or you might be using just the ingest mechanism through Elastic, like the Beats agent or Elastic agent to harvest the data and then send it to our system. So either ways, right? So you can already have the system harvested, through HTTP or maybe any of our competitors, or maybe directly from your syslog or Kafka, anything, you can pretty much load balance it and either directly ingest it through ingest pipeline. You can also build your own pipeline to Elasticsearch, or you can use a Logstash mechanism, which is again a free, completely free, architecture with which you can enhance the data, further enrich the data, and then remove the unwanted fields. Have only the fields which you really needed. Do all the filtrations, and then send the data to Elastic. Now, with the Elastic concept, you don't dump the data or the raw data directly to Elastic, right? Even if you're trying to dump the raw data, it will put a schema in place, like a pair of key value pair kind of sorting. That will be done, and that will be stored in the data nodes. Now, the place where you actually ingest the data is, we call it hot layer, and from hot layer, we have multiple tiering where you can actually have like a warm, maybe the data is 1 days old, 1 day old. You can push it to a less expensive hardware, and then put from there you can push it to a cold or a frozen layer like a data store, like probably an S3 or somewhere, and then store the data for a longer period based on your PCI compliance requirement or any compliance requirement if you want to keep the data for a long period. So we give you the flexibility of that. We don't stop it there. You can also search directly without rehydrating from your data store. You may have to store about 100 terabytes of data on a S3, but you might be worried that if you wanted to search something, it's going to take hours or days. No, that's not the matter. It does the search in probably in a few minutes, so you can get the data from a very old data store in about a few minutes to the thing. And you don't have to move the data back to the data nodes. You can directly search as a snapshot directly from the S3 storage. And then you're going to use, if you wanted to use the machine learning on the data which you bring in, or if you wanted to ingest the data somewhere else, or maybe if you wanted to just view the data on your Kibana dashboards, because Kibana is the eye through which you're going to see the data getting into the Elastic system. Hope that makes sense. And thanks. And back to you, Navi.
So I'm going to show a quick demo of Elastic Observability solution. So I have logged into Elastic user interface. Let me give you a quick orientation. On the left hand side menu, I have the access to the dashboarding and be able to create machine learning jobs, things like that, access to observability, security, and also the management aspect. So this is where I would do all that. For this demo, I'm going to go into the observability. Depending upon your role, you will frequent into any one of these areas, either logs, infrastructure, APM. So in this case, as a DevOps person, I'm going to go into service map. Service map is a visual layout of all the applications or services that I'm monitoring and the dependencies of them. I can see that Elastic allows me to categorize them. So I can categorize by production, pre-production, staging, things like that. And I can quickly see that this particular service is marked in red. I click on it to see a very high level performance metrics. I can also see Elastic Machine Learning has identified some anomalies. This is the part that Shankar will be covering later on. So as a DevOps engineer, I want to see the details. So I can quickly see this application is built on Java, deployed on Kubernetes, hosted with GCP. I can even see different versions of Java being used in this application. Again, if I'm an SRE or a DevOps engineer, I don't have to hunt for this information through the documentation, slacking people, any of that. All that information is presented to me by Elastic. Now I can look at some of the performance, key performance information about this service. I can see there are some errors being logged, the span time, things like that. I want to drill down into this particular transaction that seemed to be causing the issue. Again, performance metrics pertaining to this particular transaction is shown to me. I can look at the latency distribution, and also I can have Elastic do a latency correlation. So what Elastic is doing in the background is to looking at the current performance degradation or the latency data, comparing it with the past historical latency information for the same application, and identifying potential costs. So I can see that it is suggesting most likely the service version upgrade that we did recently to this application is probably causing the problem, and it has also identified a couple of other potential costs as well. I want to zoom into a specific section. All I have to do is select in this UI, and it'll automatically zoom information specific to that particular um, transaction. I can see the various calls, the whole timeline. And what I'm interested in is to see in the context of the whole full server trip, the full user experience. I'm going to click on View Stack Trace to do that. Now I'm presented with the full server trip, starting from the user clicking, going through different application calls, even to the level of database call. Because we have all these logs, metrics all in one place, Elastic is able to stitch them all together using trace ID, applying Elastic Common Schema. It is able to stitch all this data together for me so I can get some valuable insights. If I want to investigate further, I'm going to click on Investigate, and I can go take a look at um, container logs. Now, we started with a service map. We dove into a specific application and a transaction. And then now from here, I can go into the logs specific to this application. Now I'm in the log section. In a typical um, scenario, you may have a different application for logs in a different team, and they're all disconnected. Here, the power is to have all that information and all the team leveraging the same platform, such as Elastic. So I'm looking at the logs, and I can quickly select certain keywords to be highlighted or tracked for me. This is a log stream. So as the log comes in, this screen will get automatically updated. So I can see that it's a specific, and I can set up this filter, then it will start highlighting this particular word. So I want to just go take a look at this particular error message in the context. Why would I do that? Because now I can see what happened before or after this particular error message has been thrown. We talked about early in the stage about how data gets enriched. So you can see some of the values here, right? So you may have only few fields in the log file, but Elastic can enrich them with a whole lot of information. So the cloud provider, so all this is our standard, what we call ECS fields, Elastic Common Schema fields. So this allows you to get even more richer insight by correlating information. So investigate this further, I can go back to APM right where we started. So we started at the service map, we drill down into an application, to a transaction, to a specific log entry. Now we are back to APM. So they are all connected together. So in summary, you can see how Elastic allows you to have log, metrics, APM data in one system and be able to get powerful insights by connecting and correlating all this data together. And I want to show you one more aspect. So this is all in the observability section. If I want to get further, I can do that by going into the dashboard section. So here I can leverage any data that I have in Elastic and build my own visualization, ask some questions about data. So Elastic provides some pre-built dashboards, and it's very user friendly for me to create my own dashboards as well. All right, so again, these are some of the metrics that I can build the custom dashboards from. So one final thing, this is all exciting, but I want every one of you in this webinar to get your hands on this. So what I encourage you to do is to go to elastic.co/cloud, and you can sign up for a free Elastic Cloud instance. Once you sign up, you will see something like this. It's the same capabilities that I showed you. On the left hand side, you'll have ability to create dashboards and access to all the access to all the Elastic applications. Click on try sample data, and there are 3 different data sets provided to you for you to play with. So click in one of them. So in this case, I have added sample weblogs. I recommend you try that. And then I go to dashboard. Now you have a sample data that you can play with. This is a pre-built dashboard based on the data. So now you can see, just taking the web traffic log files, Elastic is able to plot the data in the map, show me the heat map, and also categorize error messages based on the severity. So this is a shiny new toy that I would like all of you to get your hands on. So please feel free to go to elastic.co/cloud, sign up, load the sample data. You can also import your CSV data as well if you want, or build integrations to your external applications. So it's all yours. Have fun. And that concludes my part of the presentation. I'll pass it on to Shankar to talk about machine learning and the demonstration of it.
Thank you. Um, Hope that gave you an idea of how the Elastic Observability works. I hope you can hear me right. Uh, so, so the machine learning comes into the picture only when you want to operationalize your data, right? So you basically collect all the data from different resources, from your endpoints, from your sources, all your servers, your applications, your networks, and everything comes into the picture, right? You might have say 20,000 different appliances where you're getting the data from. You might have 100,000 appliances where your data is coming from a distributed architecture. Or you might have a Kubernetes architecture where you are having multiple processes which are running in different locations. So you want to have a place where you can actually correlate that data and bring in some value out of the data. That is the idea of the machine learning here. Now, for Elastic, machine learning is a first class citizen. And so we invest a lot of our money on bringing in the Elastic machine learning process. Now, we wanted to make it very simple and very advanced for users to get value out of it. Now, the best part is with just one license, the entire Elastic suite is given to you, which includes the machine learning, right? Which includes the observability, which includes your application search, which includes your SIM security, SOAR capabilities, EDR, XDR, all of those capabilities are included in just one license fee. Now, you wanted to monitor Kubernetes? Yes, we can do that for you. You wanted to have a machine learning which understands the way the pods are being generated, the pods are being hosted, the pods are being killed, right? The pods are performing. So everything can be um, monitored using machine learning. So there's one audience among us who was actually asking about how we can alert and do automation on the alerts from a large data set from different resources. Well, machine learning is the answer for you. So the machine learning has the capability of understanding every data which enters your system at the ingest layer. And since the data is already going to have a schema in place before even getting into the index or before even getting into the table as a data, it can understand if there is any anomaly and can keep the learning, and it can go ahead with a continual learning process of the data and go forward. So let's go to the next slide and try to understand what are the different approaches we have towards the machine learning. We have primarily two approaches. One is the unsupervised, which is the anomaly detection. So basically, you can set anomaly pretty much on anything, any field on your data, any event on your data, right? Pretty much anything. And once you set that, it's going to learn all by itself, and then it's going to, you can have multiple ways to for that to communicate to you. You wanted that to communicate with you on a Slack or maybe an email or a PagerDuty, or maybe you want that to create a Jira ticket. It can do pretty much anything for you automatically without making any noise. Basically, it won't just alert you based on just the events. It will understand, correlate everything, and then give you a alert based on the severity of the issue and where exactly it's happening and why is it happening. And similarly, you have the supervised machine learning. This is where you can actually do a regression analysis or a classification analysis. So those kind of analysis can be done here in this supervised machine learning. And if you have any third party, or if you already have a built model, you wanted to bring in the built model to us, we can take that model using our ELAM tool. And then if you have anything like Jupyter notebooks in your system, we can consume that, and then we can use that as a supervised model with on the data which is stored on Elastic. Right. Now, the main the difference is you have to have a label data for supervised, and and then for unsupervised you don't need that. Right. So, how does the machine learning work? Now, if you look at this, you have the anomaly detection, and the data is driven into the system, and then we can have multiple anomaly detection engines created, like machine learning engines created, and then sit at the inference level. Like when the data is getting into the system, you can just put like a barrier right at that data. It won't delay the data from getting into the system. It'll just watch the data, understand the data, understand the pattern, and then it'll do two things. One, it will learn for itself. Two, it'll do actions like alerting or staying quiet. Similarly, with label data, you can do the analysis either at the ingest layer, or once the data comes into the system, and do a summarization of data automatically, and then bring the value of the supervised machine learning, like any analytics out of that data. Okay, so how about the time series? All of these things which I was talking about is all about time series. So it's basically learning, predicting, and operationalizing, and that's the three jobs it does it better, right? And if it needs some alerting, it just go ahead and alert you. So these are a couple of screens, I believe, you just saw how it works. Let's do one thing. I'm going to share a screen quickly. Hopefully you can see the screen there. Scott, can you see
Yep,
me?
Shankar, I see your screen. Yep, looks good.
Okay. Okay. So this is the cloud interface which Navi just showed it to you, right? You can have a free subscription and uh, host the data. You can put your own data, or you can bring in the data which is already there in the system, and then you can go ahead. Now, when you go to the main menu here, click on the machine learning, and then the machine learning page opens up here. And here you want to see how much um, memory a machine learning job is going to take. So you can have hundreds of machine learning jobs, thousands of machine learning jobs for you for a single application or whatever it is. Any range you can use it, and with a very small hardware footprint, you can solve a lot of problems out of it. So, for example, let's create a simple machine learning job for you. I'm going to create an anomaly detection. Click on create job. I have to choose a data set where I wanted to create it. Okay, so I can choose any data. I'm just going to choose some sample logs here, and then I have the option of either a single metric or a multi-metric. So I can choose any of these. So if I wanted to choose a different single metric, I can choose this. Use the full data set because I wanted the entire data set. Click on next, and then I have to just choose a field. Say, for example, if there is a high count event rate, all these fields are already available for you. All you have to do is you need to understand your use case and then do this. So high event count rate, right? It'll estimate a bucket, and you can have a bucket span of either 1 minute or probably 15 minutes or maybe even 1 hour. You can go ahead and do that, and then click on next in this place. Give a name for it. I just wanted to call it ML1. And if you want to create a tag or a group or whatever it is, you can go ahead and create it here, right? Like test one in this case, and press enter. It's going to create a group. Now, if you want to put a different machine learning job in this group, you can just go ahead and drop it down and then choose this one next time. There are some additional settings which you can do. For example, if you wanted your end user to click on a URL from where they want to go to the raw data directly from the alerting or something, you can just click on add custom URL and then call it, say, discover, and that's it. So I'm going to call it raw data, and then choose a discover and choose the data view wherever it is already done, and then time range is auto. Click on add, and that's it. So when you don't need a big data scientist to work on all of this. So any operations guys, they can do that, and they're not going to kill the system, and there is no additional cost in creating more machine learning. Okay, and then if you have a calendar where you have like a scheduled event or maintenance or something like that, you can import the calendar here, and then next here, and click on next, and that's it. It's done. Now either you can create it. This is created. Now, if you want this to be on a time series database where it's going to continuously hit on it, right? So you can, all you have to do is to convert this to a time series, just click on start a job running in real time. And that is all you have to do. That's it. Now, once this is running on a time series, then you can create a new alert role. So you click on the alert role for this particular machine learning job. And then it's going to choose the machine learning job for which you want to alert, and then you can choose whether it's a bucket or a different settings here, and then the actions you wanted it to be on email, or maybe put this all in a different index altogether, and then you wanted to process it from that index, or if you wanted to get into a webhook and build it. So because everything with Elastic is API driven, API first. So if you wanted to access it directly on a webhook, you can do that. Or other integrations like the ServiceNow or Teams or Slack or Xmatter. So anything for that matter, you can just go ahead and integrate that and save it. That's it. Pretty much simple for loading a machine learning job. So now I created one machine learning. Let's see how much memory it's consuming at this point of time. So I can see that this is the machine learning, right? I can see how much it's consuming here. I have one job, and the total memory on this particular machine is only 1 GB. Okay, and I can see that the JVM has taken about 400 megabyte, and then the memory available for the machine learning job is 576 megabyte in total, right? And this one particular job is taking only 40 MB out of that. Now imagine if you have a 64 MB machine, and then you have about 20 MB for the JVM, and the rest is for the for the estimated available memory. You can have so many jobs just running on one license, because 64 gig is one license as per elastic terms. So if you have one license, you can have, for the ML, you can have numerous number of jobs. And that's, I'm talking about a small a small environment where you have about say 5 terabytes of data per day, or 10 terabytes of data per day. Now, if you have a larger place where you have about a petabyte of data coming into the system, which includes logs, metric traces, your syslogs, your network logs, all of those logs, well, you just need to have a small cluster of ML machines, and then that can handle the job. It's not going to be super expensive to run a wonderful machine learning jobs across that. Okay, well, it makes sense. And if you wanted to have a train model, you can bring in your own train model using Skagit and a couple of other things by which you can actually see it. So that's about the machine learning which I want to talk about today. Uh, okay, so we can open it for Q&A.
Okay, great. Um, yeah, let's see. We've got some questions coming in here. This first one, Shankar, is how does Elasticsearch incorporate machine learning capabilities, and what are some common use cases for leveraging machine learning with Elasticsearch? And you went through some of that, but I think they're looking for a little more detail.
Uh, okay, some of the questions. So you wanted to understand how the machine learning works.
Yeah.
Is that right?
Yep.
Okay.
Yeah.
Well, basically, the machine learning jobs will work on the ingest layer. So when you try to ingest the data into the system, into the Elasticsearch, either through a Logstash or any medium from where it's getting into the system. So we will have these machine learning jobs, which will have a set of attributes defined, like if my event count, if I have 200 number of 200s, or if I have too many hits on my website, if I have too many number of clicks on a specific submit now button or something like that. You can come up with any kind of situation. So something which is not normal during that hour of the day, that day of the week, or that week of the month, or that month of the year, the anomaly will have a learning done as the data is getting into the system, and then it will go on with a continual learning process and then alert you based on that.
Okay.
Did it answer?
All right, great. Yep. Um, Here's another question for some more detail about observability. What is observability, and how does the Elastic Stack help organizations achieve greater observability across their systems and applications?
Well, in general, if you look at that, now the observability will measure how well a system's internal states can be understood by examining its external outputs. Now, Elastic, the full stack, will help you organize all those, and then achieve a greater observability, providing you for tools for collecting all your information, which includes the logs, metrics, traces, and then there is a place to store it in a cost viable fashion, and then analyzing and visualizing the data directly from multiple various resources across the your thing, and then in a much faster way. Now, if you look at how Elasticsearch works, we have these Elastic agents. It's like a little agent which sits on the host and sends you the data. Now you can have that, and you don't need to literally have that. You can send the data, process the data to either Logstash. Again, that's a free one. It's all open source. And then from there to Elastic. Now Elastic is the only one where you can actually buy license and use it for a commercial engagement, right? So now all these
Yep.
will work on a correlation methodology, and the correlation engine within the system will work live. It will not, I mean, it doesn't work on some old data. We are talking about terabytes of data getting pushed through the system, the logs, the metrics, the traces, and correlating all of those and giving it to you in one place where there is some sort of alert which talks about there is a delay when they click on this particular button, right? Like a order now button or something like that. Now you have to trace back and see what is actually causing the problem, whether it's a hardware, it's a network, it's a software, it's a process, whatever it is, right? So we need to find it out, whether it's a new release which is actually causing the problem. You need to go back, analyze the day before and the day, the week before the new release has been done. So there are a lot of factors which goes into understanding your data before alerting you on the observability. So observability is going to give you a full view of your entire stack.
Okay. All right. Excellent. Um, there's another question here, looking for sort of an overview of the Elastic Stack and its components and how those work together. You were talking a little bit about the agent there, but anything else to say just about the stack itself, the components of the
Sure.
stack?
Yeah. So let me be very clear in saying that you have to collect the data and you have to analyze the data. Starting from the left to the right, let's talk that way. On the left side, you have all the sources. Okay, let's keep um, a simple infrastructure in this case. I have say five web servers, and that's all I have, right? So all I have to do is just install this a little lightweight agent on those system, and that's going to bring up the data, collect it, and put it to the next level for further processing. You can actually process the data right at the agent level, and then further processing can be done at Logstash, which is going to act like a middleware. You can skip Logstash also, depending on how you want to process the data, and send the data directly to Elasticsearch. That's all it is. Now, from Elasticsearch, you have multiple ways to view the data, report the data, or maybe process the data. Whatever you want to do, you can do that. Now, for doing that, for accessing the Elasticsearch, either the data on the Elasticsearch or configuring the Elasticsearch, you need an interface, and we call it Kibana. Kibana is again open source. You can use Kibana. It's a web-based, user interface. Uh, you can pretty much use it for visualizing all your data, managing your data, and creating RBACs and creating different level of security for your data, and then giving access to a different set of people, different organization within your company. So all those managing things can be done using Kibana, and that's the last visualizing layer. And the
Okay.
other thing to
Excellent.
that is we provide a two options here. One is on-prem. You can have a complete on-prem on your place, or you can have a completely hosted solution. It's a managed solution. So we manage your infrastructure in AWS or Azure or GCP, and then we can take care of everything. So you don't have to worry about hosting the machines or doing upgrades on the machines or uh, security patches or anything like that. You don't have to worry about that. Just send the data. We'll take care of it. You just manage the users and their permissions and stuff like that, and manage the data. That's it.
Okay. Excellent. Well, we're probably getting up on time here. You've been really generous with your time, but Ned has a question that's always a good closer. Ned's wondering, how does one get started with Elastic? You guys showed a few things there in the demo, but any closing thoughts on getting started with Elastic?
It's pretty simple. You can see that here on the screen. Elastic.co/cloud. Just go there. You don't have to put any credit card details. You don't have to put your official email ID. You can pretty much sign up for that. It's a 14-day trial, and it's a full-on trial. You wanted to check your Kubernetes functionalities. You wanted to check your syslogs. Anything can be ingested into this. There is a ton of integrations on Elastic which you can do out of box, and then you can start using it. And there are a lot of training videos right on the website which talks to you about how you can integrate data, how you can bring in the data, everything. So if you go to Elastic Docs, there is a Docs option on every screen at Elastic. So click on that, and that's going to show you the steps of how to integrate that. Now, if you think your company is going to be benefited with this, you can contact our sales, and then we can help you set up a very good POC environment, either on a cloud or maybe on-prem, depending on your requirement, and then we can take it further.
Okay, fantastic. Well, Shankar and Navi, thanks to both of you for putting together a really informative presentation here today, and for all your insights in the Q&A. We really appreciate your time.
Absolutely. Yeah. Thank you very much.
And as far as do check out that elastic.co/cloud for more information. And finally, before we wrap up, we have one more piece of business, and that's the Amazon gift card prize drawing. And the winner of that $250 card today is Shiva Somishati from California. So congratulations to Shiva. We'll be in touch to get you your card. And with that, on behalf of the Actual Tech Media team, I want to thank Elastic for making this event possible. Thanks to Navi and Shankar again, and thanks to all of you again for attending and for your great questions. That concludes today's event. Have a fantastic rest of your day.